Hello everyone. Wish you a very happy new year. Hope you started your new year with a lot of positive vibes. Stay healthy, stay happy, stay focused and keep studying. My name is Arpita Banerjee and you are watching Arpita classes. So in our previous video we started with the sums from mensuration. We did some of the sums from Selena publication. Today I'll continue with the same chapter, but I'll be doing the sums which have already come in the board examination before. So these sums are very important in the point of view of board examination. Let's get started. The first question is, the surface area of a solid metallic sphere is 1256 centimeter square. If it is melted and recast into solid circular cones of radius 2.5 centimeter and height 8 centimeter, find the radius of the solid sphere and the number of cones formed. They have given the value of pi, that is 3.14. So whenever something is melted and recast into a new figure, the volume remains constant. So here we have two figures. One is a solid metallic sphere and which is melted and recast into some cones. So let us first write down the information given in the question. So here I am writing the solid sphere and in the other column I am writing cone. So solid sphere is the surface area of the solid sphere is given, that is 1256 centimeter square, which is melted and recast into right circular cones of radius. Radius, I am denoting the radius of a cone by small r, which is 2.5 centimeter, and height, which is 8 centimeter. So we need to find out the radius of the solid sphere and also the number of cones formed. So we have considered the number of cones formed is n. Now here surface area is given. Surface area of a solid sphere is 4 pi r square. So I will write 4 pi r square is equal to 1256. Now let us put the value. R I am putting as 22/7, or you can put as 3.14 3.14 into r square is 1256. So r square will be 1256 divided by 4 into 3.14. So we need to calculate here to get the value of r. So I am cancelling this 434144. Now this is 314 and this is 314 upon 100, that 100 goes up. 314 gets cancelled. So we get r square is 100. Therefore the value of r will be 10 centimeter. So we got the value of r, that is the first part. The value of r is 10 centimeter. Now, as the solid sphere is melted and recast into number of cones, the volume remains same. So in the second part, this was the first part. In the second part, we are going to write volume of solid sphere is equal to number of cones formed is n. We have considered. So n into volume of cone. Now volume of solid sphere is, the formula for that is 4/3 pi capital R cube is equal to n into volume of cone. Formula for that is 1/3 pi r square h. So now let us cancel pi and pi from here, 3 and 3 from here. So we get 4 r cube is equal to n into r square into h. Let us put the values now. 4 into r cube, r is 10, so 10 cube is equal to n into r square is 2.5, so 2.5 square into h is 8. So the value of n would be 4 into 10 cube. Now I am going to write 10 into 10 into 10 for 10 cube divided by 2.5 whole square. So 2.5 whole square I will be writing as 25/10, that 10 will go up. Another 25/10, that 10 will go up and 8 is coming down. Now let us calculate 24 and 4 is 100. This 24 and 4 is 100. 4, 2 and 2, 2. So I am getting, in the numerator I am getting 2 into 4 into 10. So that is 80. 4 to 8 into 10, that is 80. So how many cones are formed? 80 cones are formed. So let us start with the next sum. A hollow sphere of internal and external diameters 4 cm and 8 cm respectively is melted into a cone of base diameter 8 cm. Find the height of the cone. So here again a hollow sphere is melted and a cone is made. So I'll make two columns. One is for hollow sphere. I'll write down the dimensions of hollow sphere here, and the other one is cone. So internal diameter and external diameters of the hollow sphere is given. Internal diameter I am considering is small d, which is 4 cm. So internal radius will be 2 cm. External diameter capital D, which is 8 cm. So external radius capital R will be 4 cm. And the base diameter of the cone is 8 cm. So base diameter of the cone is denoted by D dashed, which is 8 cm. So the base radius R dashed will be 4 cm. So here in this case again, volume of hollow sphere would be is equal to volume of cone. Now volume of hollow sphere will be pi 4 by 3 pi capital R cube minus 4 by 3 pi small r cube. Right? Because it's a hollow sphere. So the outer sphere, volume of outer sphere minus volume of inner sphere will be is equal to volume of cone, which is 1 by 3 pi r dashed square h. Volume of cone is 1 by 3 pi r square h. Let us take common 4 by 3 pi. So it will be r cube minus small r cube 1 by 3 pi r dash square h. Let us cancel pi and pi, 3 and 3. So we get 4 capital R cube minus small r cube is equal to r dash square into h. Now let us put the values. 4 capital R cube is 4 cube minus small r cube is 2 cube. R dash square, which is 4 square into h. So now this is 4 into 4 cube, 4 4s are 16, 4s are 64, minus 2 cube is 8 is equal to, this is 4 square, we'll keep it as 4 square only, or 4 into 4 into h. So here it is 4 into subtracted 56 divided by these two 4 will come down is equal to h. 4 and 4 gets cancelled, 4 1 4 4. So h is equal to 14 centimeter. They are asking for the height of the cone, so the height of the cone is 14 centimeter. So let us start with the next question. A vessel in the form of an inverted cone. A vessel in the form of an inverted cone. So let us draw this diagram. This is an inverted cone. A vessel is in the form of this. Its height is 11 centimeter. So the height of the cone, which is this, is 11 centimeter. I'll draw it in a proper manner. Yes, so this height is 11 centimeter and the radius of its top, which is open, is 2.5 centimeter. So the radius of the top, this is 2.5 centimeter. When laid shorts, each of which is a sphere of radius 0.2 centimeter are dropped into the vessel. That is, you are dropping laid shorts like this into the vessel like this, which a sphere of radius 0.25 centimeter. 2/5 of the water flows out and it was filled with up to the rim. So it was filled with water up to the rim. When you are putting this inside the vessel, 2/5 of water flows out. 2/5 of water flows out. Okay. So you have to find out the number of laid shorts dropped into the vessel. So again, this is based on Archimedes principle, that is the volume of the laid short will be is equal to the volume of the water which is flowing out. Okay. So here we have one cone and the other thing is laid shorts. We are making two columns and write down the information given. The height of the cone, h is equal to 11 centimeter. I am putting it capital H, denoting by capital H, and capital R is 2.5 centimeter. Convert it into fraction, 25 by 10 centimeter, that is 5 by 2 centimeter. And the laid short, I am putting the radius of laid short as smaller, that is 0.25 centimeter, that is 25 upon 100 centimeter, and which is equal to 1 by 4 centimeter. let the number of lead shot be n. We have to find out n. So here volume of water flows out is equal to n into volume of one lead shot. Okay? So n number of lead shot will be whatever will be the total volume of n number of lead shot, that will be is equal to the volume of water which flows out. And how much water is flowing out? 2/5 of the water flows out. That is 2/5 of volume of cone, because the water was filled till the rim. So whatever was the volume of the cone, that was the total volume of the water initially, and now 2/5 of that volume of water is flowing out is equal to n into volume of lead shots. Okay. Now 2/5 of volume of cone. Volume of cone will be 1/3 pi capital R square H. Here volume of lead shot will be 4/3 pi small r cube. Okay, let us cancel pi and pi, 1/3 and 1/3. So it is 2/5 into r square. R square is 5/2 into 5/2 into capital H. Capital H is 11 is equal to n into r cube, and your r cube is 1/4 into 1/4 into 1/4. So we need to find out n now. I'll do it here. So n will be is equal to, first I'll write whatever is written this side, that is 2/5 into 5/2 into 5/2 into 11, and now this 4, 4 and 4 will come up. It will be in the numerator. Here it is not fitting, so I'll have to rub some part here. I'll be rubbing this part. Okay, so from here I'm doing it now. N is equal to, first I'm writing whatever is written this side, that is 2/5 into 5/2 into 5/2 into 11. Now this 4, 4 and 4 is coming this side, so they will be multiplied. 4 into 4 into 4. So 5 and 5 gets cancelled, 2 and 2 gets cancelled, 2 and this is 2. So we get 11 into 5 into 2 into 4 into 4. So 4 into 4 is 16, 16 into 11 and then into 10. So 16 into 11, let us check. (176). 176 and 5 2s are 10. So 1760 is the answer. So number of lead shot is 1760. Number 4 in front of you. A girl fills a cylindrical bucket 32 centimeter height and 18 centimeter in radius with sand. So there is a cylindrical bucket, I am drawing it, which is 32 centimeter in height. So the height of this is 32 centimeter and 18 centimeter in radius. So this radius is 18 centimeter. This is filled with sand. The girl is filling it with sand. She empties the bucket on the ground and makes a conical heap. Now this is emptied in a ground and a conical heap is made like this. This is a conical heap which is made by this sand. Conical heap is, the height of the conical heap is 24 centimeter. So this is 24 centimeter. You understand, it is like symmetrical. So the height of the conical heap is 24 centimeter. We have to find out the radius of the conical heap R and the slant height of the conical heap. Okay. So now again it is, the concept remains same, that the volume of the cylinder, since it is filled with sand and now the sand is emptied on the ground and the conical heap is made. So the volume of the sand in the cylinder will be equal to the volume of the conical heap. Okay. So here there are two figure. I am writing the cylinder, that is one figure, and the other figure is cone. The height, the cylinder 32 centimeter in height, h is equal to 32 centimeter, denoting it by capital letters, and radius, that is capital R, is equal to 18 centimeter. This is for the cylinder. And the conical heap, the small height h is equal to 24 centimeter, and we need to find out R is equal to what and L is equal to what, slant height and radius. So volume of sand in cylinder will be is equal to volume of conical heap. This is the concept. So volume of sand in cylinder, that is pi capital R square H, will be is equal to 1 by 3 pi small r square h. Pi gets cancelled. So capital R square h, that is 32 into 18 into 18. R square is 18 into 18 into 32 is the height, is equal to 1 by 3. R square we do not know, height is 24. Here it will get cancelled 8. Get this 8 this side. 32 into 18 into 18 upon 8 is equal to R square. 8, 4. So we are getting R square is equal to 4 into 18 into 18. So R would be is equal to 2 into 18, that is 36 centimeter. So the radius of the base we got 32 centimeter. Now we have to find out L, which we can get by Pythagoras theorem. That is L square is equal to A square plus R square. I'll do it here. The second part, that is we need to find out the slant height. That is L is equal to root of A square plus R square. The A square is 24 square plus R square, that is 36 square. So we need to find out the squares and then we have to leave the answer in square root form only. So 24 square is 576 plus 36 square, which we need to see. (1296). So 1296 plus 576, 1872. So the answer will be root of 1872 centimeter. They are saying to leave the answer in square root form, so we can leave the answer here. The slant height of the figure will be root over of 1872 centimeter. So the next question, question number 5. A metallic sphere of radius 10.5 centimeter. So we have a sphere here which is of radius 10.5 centimeter, is melted and then recast into small cones. There are small cones, many small cones are made which are of radius given, that is 3.5 centimeter. Radius is 3.5 centimeter and height is 3 centimeter. We have to find out the number of cones. Again the concept remains same. This is melted and recasted into another figure, so the volume of both the figures remain same. So here volume of, directly writing, you can write down the information given first. Volume of sphere will be is equal to n into, because we are considering n number of cones are formed, n into volume of cone, volume of each cone basically. So volume of sphere is 4 by 3 pi capital R cube is equal to n into volume of sphere 1 by 3 pi R square h. First we'll cancel pi and pi, 3 and 3. So we are getting 4 R cube is equal to n into R square h. Now let us put the formula values. Sphere is 10.5, so 4 into 10.5, I will be writing it as 105 upon 10. Now since it is cube, so it will be 3 times into 105 upon 10 is equal to n into R square. R, small r is 3.5, I will be writing it 35 upon 10, 2 times because it is square, into height is 3. We can cancel it, 5 to 5, 21. So this will be 21 upon 2. So I am writing 4. This will get cancelled also. So I am getting only 21 into 21 into 21 upon 2 is equal to n into, even this will get cancelled, 5, 7 by 2, 7 by 2. So 7 by 2 into 7 by 2 into 3. Now n we have to find out, so we will get everything this side. So 21 into 21 into 21 upon 2 is here. 2 and 2 will go up, 7 into 7 into 3 will come down is equal to n. Whatever is in the denominator, that will go up in the numerator, whatever is there in the numerator, that will go down in the denominator, because we are changing the sides. So here 7 into 3, 21 and 21 will get cancelled, 2 and 2 will get cancelled, 7 and this will be 3. So n is equal to, we are getting 3 into 21 into 2, that's all. So 2 into 3 is 6, so 21 into 6, that is 126. Yes, 126 number of cones are formed. Number 6. A vessel in the form of an inverted cone is filled with water to the brim. I'll draw it so that you will understand. A vessel in the form of an inverted cone which is filled with water till the brim. That is, the volume of cone is equal to volume of water inside it. Its height is 20 centimeter and diameter height is 20 centimeter. So the height of the cone is 20 centimeter and the diameter of the cone is 16.8 centimeter. So we can get the radius from here. Two equal solid cones are dropped on it, so that two equal solid cones are dropped on it. This is one cone and this is another cone. These two cones are equal. They are dropped on it so that some water flows out. And how much water flows out? 1/3 of water flows out. You have to find out the volume of each of the cones submerged. So obviously 1/3 of water flowing out, that means whatever amount of water is flowing out, whatever volume of water is flowing out, that is the volume of these two cones. According to Archimedes principle again, if you are submerging these two cones inside, whatever amount of water is flowing out, that is the volume of these two cones. So volume of each cone will be divided by 2. That is the concept. So here the bigger cone has the height 20 centimeter and the diameter 16.8 centimeter. So the radius will be divided by 2, that is 8.4 centimeter. Okay. So volume of cone is equal to 1/3 pi r square h. So volume of cone, that is volume of water inside the cone. Now 1/3 of water flows out. So that 1/3 of water is the volume of two cones. So we'll write volume of two solid cones is equal to 1/3 volume of original cone. That is 1/3 of 1/3 pi r square h. This is volume of two cones is equal to. So now put the values. 1/3 into 1/3, 22/7. R square is 8.4, so that 84/10 into 84/10 into h. H is 20. 0 and 0 gets cancelled. 7, 1, 2, 3, this is 4, this is 3, 2s are 6 to 8, and this will be 5. So it is 4 into 22 into 28/5. 22 into 4 into 28/5. This is the volume of two cones. So volume of one cone will be, I'll do it here in here. Volume of one cone is equal to, so this volume will be divided by 2. This is the volume of two cones, so that will be divided by 2. So it is 4 into 22 into 28 divided by 2 into 5. So what we can do is, we can see here it is 5 to the 10, it's coming 10. So we just multiply the numerator and divide it by 10. That is, shift the point left hand side, one digit left hand side. So 22 into 4 is 88 into 28. Two 464/10, that is 246.4, and the unit will be centimeter cube. So this is the volume of each cone which are submerged. So we will be moving towards the next sum, 7th sum, which is the last sum for, in today's video. They are saying the surface area of a solid metallic sphere is 616 centimeter square. Surface area of a sphere is given, that is 616 centimeter square. It is melted and recast into smaller spheres of diameter 3.5 centimeter square. So there is a metallic sphere solid which is melted, and number of spheres of smaller dimension is made. We have to find out the number of such spheres formed. So first of all, surface area is given. Surface area is 4 pi capital R square. I am denoting the radius of the bigger sphere as capital R. 4 pi R square is 616. So 4 into 22/7 into R square is equal to 616. So R square would be 616 into 7 divided by 4 into 22. Let us cancel and see what is it coming. 11 gets cancelled by 11. 11 2, 11 5, 11 6, 4 14 and 2 7. So r square is coming 7 into 7, that is r is equal to 7 centimeter. So we got the radius of the bigger sphere. Now this sphere is melted and recast into smaller sphere. So again we will see the volume of the spheres will remain same. So we'll write volume of bigger sphere is equal to, we are considering n number of smaller spheres are formed. So n into volume of smaller sphere. Volume of bigger sphere 4 by 3 pi capital R cube, n into volume of smaller sphere 4 by 3 pi small r cube. 4 by 3 pi will get cancelled. Sorry, here pi is also there. Will get cancelled. So r cube is equal to n into small r cube. Capital R is 7. So 7 into 7 into 7 is equal to n into small r. Now the diameter of the smaller sphere is 3.5. That means if the diameter is 3.5 centimeter, the radius is 3.5 upon 2 centimeter. And I'll convert it into fraction. So 35 upon 10 into 2 centimeter. So 5, 7 and 5, 2. So it will be 7 by 4 centimeter is the radius of the smaller sphere. So I'll put it here 7 by 4 into 7 by 4 into 7 by 4. Now n will be is equal to, first I'll write 7 into 7 into 7. This 4 will go up, 4 into 4 into 4 will go up, and 7 into 7 into 7 will come down. 7 gets cancelled. N is equal to 4 into 4 into 4 cube, that is 64. So how many such spheres will be formed? There will be 64 such kind of spheres which will be formed. So we have covered all the board sums here today. These sums are right from, they have come to the board right from 2002 onwards. So we will continue these board sums in the next video also. Thank you so much. Stay tuned.